I'm trying to make a self-steamer but with recycled materials. In my last video, I demonstrated how I built the motor section using 2 motorcycle forks and spare parts I had available. Let's say there are 3 fundamental parts of a self-steamer. The engine, which we already have built, the boiler, which will be responsible for generating the high-pressure steam to move the engine. Lastly, a vehicle on which all of this can be mounted. There are 2 common designs for making a boiler. The first is to make a continuous steam boiler. These work by heating the water through a copper coil, using the steam that comes out the other end at high pressures. And the second is to heat stationary water, for example, inside a tank and use the steam as we need it. Now you'll see how. First, and with the idea of continuing with this vintage or old-fashioned style, I got this old water heater that was used to heat water in bathrooms. Honestly, I don't know how old it is, but it's probably over 50 years old. It's all made of copper and bronze. What interests us here is this. First, its shape, which is very suitable for a boiler. And the other thing is that inside it has a huge copper coil, and this is what we're going to use to heat the water. The copper pipe can handle pressure very well, making it perfect for our needs. This is where you'll learn why I decided to combine the 2 boilers. If I only put fire underneath and heated the water, I would have constant steam. But to modify it, I added a small gas cylinder on the top. This cylinder is connected in such a way that it connects both to the outlet and the inlet of the copper coil. But of course, it couldn't be just like that. I had to modify it. First, I made a hole at the bottom of the cylinder, and right there, I welded a thread. This was so that I could later screw in the fitting that would allow me to connect the copper tube. I connected the coil's outlet to the top of the cylinder, where it had the factory thread. This is done so that when the cylinder has water, the water, by gravity itself, is pushed into the coil. And then, by simple expansion, it continues its way to the top of the cylinder again, where it would start to build up pressure to be used later. Let's talk about the safety elements I put in. Obviously, since we're working with high pressures, we can't just leave everything to chance. First, I put a valve on the cylinder so I can open it and release the pressure as well as to be able to fill it with water. I also added this safety valve to it. If the pressure exceeds around 140 pounds per square inch, it opens to release the excess steam. And finally, I put a pressure gauge, which is to constantly measure the pressure inside the boiler. After assembling everything, I tested it, which in hindsight was not a good idea to do inside the workshop. The filthy water heater filled the entire place with smoke within a minute. For the second test, I took it to the garden, let it heat up, and everything seemed fine. It was building up pressure, but not too much, since I was only running it with oil. The idea was for it to run on coal, but when I tried to start using coal, everything became a problem. Despite trying various methods like blowing air, creating continuous airflow, and sealing it completely, I couldn't get it to heat up sufficiently. Then I realized I was using the wrong type of coal. The coal we use for cooking is fine, but for industrial use it's terrible. That's why I decided to use this. This is what's known as coke coal, a special enriched coal that burns at a very high temperature. It's what's used, for example, in forges and in places where people work with metal. It can reach over 1,000 degrees. As I understand it, that's why it's perfect. To start, I cut fire bricks and placed them on the walls and floor of the boiler's bottom part. This concentrates the heat. Obviously, the coal doesn't light up by magic, and this is where I use my other trick up my sleeve. Quebracho Colorado firewood, a very hard wood that burns at a high temperature, was used to fill the boiler in combination with another type of wood. Once lit, it took a while to catch, but then it got really hot. I exceeded the maximum pressure and the safety valve activated successfully. The problem here was that both the safety valve and the pressure gauge, once they did their job, exploded. They're not designed to operate at these temperatures. And this is what's called a siphon tube or pig's tail. It's a tube connected before the pressure gauge, responsible for condensing steam to prevent liquid from damaging the gauge. With this, we could get back on track. He had an old vintage train whistle that made a very nice sound. And he wanted to put it on the boiler. I thought of putting it on the valve. Since I didn't really know how to attach it because it didn't have any threads or anything, I soldered it with tin to a threaded piece and put it there. After another round of testing, everything worked flawlessly. Nothing seemed damaged. The only thing was that when the safety valve opened, the tin I used melted and the whistle fell off. I'll keep trying other methods. I repeatedly turned the boiler on and off. Safety, especially with steam boilers, is the top priority when operating this type of machine. Once certain, I connected it to the engine. I first tried using a hose I thought could handle high pressure, but it eventually swelled and exploded. I reconnected it using a copper tube. While the temperature increased, I tested everything, and it appeared to function properly. Water was coming out of the engine since it's the condensation of the steam because the whole system is so cold. But when the time came, the heat from the steam damaged my electronic solenoid valve, causing it to get stuck and it didn't work anymore. The valve, meant to let steam in, wasn't made for high temperatures. I need to find a replacement for the engine. I'm considering using an air conditioner reversing valve. I know it works with up to 135 degrees, but for now, I'm satisfied as long as the boiler works well. I'll post all updates on my Instagram. Thanks for watching. See you next time. Bye.